Okay, hello. Today I'm going to explain section 5.1 of Pearson calculus, which is about the area and estimate of area by using rectangles. There are 15 problems in this section. I'm going to cover some of them, but not all. Problem number 1. Use finite approximation to estimate the area under the graph of fx is equal to 9x squared and above the ground graph of fx equal to 0 from x is equal to 0 to xn equal to 16. So it is a parabola. So it is an increasing function in the interval of 0 through 16. Okay. And we want to find the area under the curve and above y is equal to 0. Part 1. So a lower sum with two rectangles of equal width. So I'm going to create two rectangles. So I'm going to divide this interval into 2. So it's going to be 8 here. Okay. And in each interval, I'm going to take a lower sum. So I'm going to take a smallest height in each interval. So between 8 and 16, the smallest y value is at the left end point, like this. And between 0 and 8, the smallest point is at x equal to 0. So the area is going to be 8 times 0 plus 8 times the height at here. So it's going to be f of 8. So the first rectangle has a 0 area, and second rectangle has a horizontal length of width of 8, and the height is f of 8. So it's going to be 9 times 8 squared. So that's going to be 9 times 8 cubed, which is 512. So it's going to be 4608. Number 2. How about a lower sum with 4 rectangles of equal length? So I'm going to have a same curve, same interval. However, I'm going to split into 4 intervals. So here's a midpoint, and you're going to take a midpoint here, and you're going to take a midpoint here. And we're going to take a lower sum. So basically, it's going to be a left end point. I'm going to use the left end point to estimate the area under the curve. Now, area going to be the sum of 4 rectangles. First one going to be the 4 times f of 0 plus length of 4 times the height at x is equal to 4 plus this one. Length is 4 and height is f of 8. And again, from 12 to 16, it's 4 times f of 12. You can factor 4 out to find just the sum of f of 0 plus f of 4 plus f of 8 plus f of 12. Now it's going to be, it's 0 plus 9 times 4 squared plus 9 times 8 squared plus 9 times 12 squared. You can factor out 9, which is going to be 36. And you're going to have 4 squared plus 8 squared plus 12 squared. You can factor out 4 squared as well. It's going to be divided by 4 squared. It's going to be 2 squared. And it's going to be 3 squared. It is 36 times 16 times 10, 14, which is 224 times 36. That's terrible. So it's going to be 6760 plus 1344. So 8064. So that's going to be the sum of the 4 rectangles. Now part 3. Now I'm going to find the upper sum with 2 rectangles. Okay, so when you want to take upper sum, you want to take the highest possible height in each interval. For 0 through 8, you want to take the right end point for the height of the rectangle here. And between 8 and 16, you want to take right end point as well. Yeah. When you have a function that is increasing in the interval, you want to pick the right end point for the upper sum and left end point for the lower sum. Now let's find the area again. So area is going to be 8, that's the width here, 8 times height is first rectangle has a height of f of 8, and the second rectangle has a height of f of 16. So it's going to be 9 times 8 square, and it's going to be 9 times 16 square. So we can factor out 9, and you can factor out 8 cube, so 8 square. So it's going to be 1 plus 4. So this is something we just found out in the part A. This is 4608, and you just multiply it by 5. So it's going to be 23040, 23040. Okay. Number 4. Again, you want to use upper sum, but with 4 rectangles. So it's going to be, again, it's going to be, I'm going to split into 0, 4, 8, 12, 16, but I'm going to take a right sum. It's going to be like this, like this, like this, and like this. Okay, so area is, the sum of the area going to be, each width is 4, and you're going to have f of 4 for the first height, f of 8 for the second height, f of 12 for the third height, and f of 16 for the fourth height. Now we are doing the similar questions. Well, this part, we basically did it at here, because this one was 0. So it's 4 times f of 4, f of 8, and f of 12 is, we just did it already, which was 8064. So we just borrow 8064 for this term because we already did it. And the rest is going to be 4 times 9 times 16 square. So that's going to be, this is 256 times 4 is 1024 times 9. So it's going to be 9216. So 17280. Okay. So that's basically finished problems. Now, let me show you one useful website to compute these, which is the Riemann sum calculator. Okay, in the symbolab.com, go to calculus. Yeah, this is calculus actually. You go to calculus and you can find the Riemann sum. When you go to Riemann sum, you will need to type integral, the definite integral. In this case, the integral, the lower number is left end of the interval. And this one gonna be the upper end of the interval. So it's, in this case, 16. The function inside, the function you wanna use is 9x squared dx. Okay, now you wanna choose at the end as a number of rectangles. So let's choose 2. So now you're gonna get 11520. This is the case when we use a midpoint Riemann sum. If we choose left points, we're gonna get the lower sum in this example. So you're gonna get 4608 with a computation here as we did it. Okay, it's 8 times f of 0 plus f of 8. If you pick right point approximation, you want to get 8 times f of 8 and plus f of 16, which is 23040. Okay, now if you pick n equal to 4, then you want to have a sum of 4 rectangles for height, and it's going to be, well, this is again, it's going to be midpoint by default. So I use left point for the lower end, 8064, and the right point for the upper sum, 17280. Okay, so this is quite useful. Okay, so let's see question number 2. Now, again, this is basically the same with just the different numbers. It's kind of tedious, but let me use this as an example to find all 4 answers here. So now interval is between 0 through 2. Okay, and you get a 5x cubed as a function. And the number of interval is, let's say, 2. Okay, all you need to know is this is an increasing function between 0 and 2. Because this is increasing function, if you pick the left endpoint, left points, you want to have a lower sum. Okay, so this is going to be the lower sum in case of 2 rectangles. If you use a right point, you're going to get the upper sum because right point has the highest y value in each subintervals. So if we use 2 rectangles for upper sum, you want to get 45. Now you just pick this one to 4. And you change this part, left point for the lower sum, 11.25, and right point for the upper sum. Okay, and the computation looks like this. So, oops. I'm just going to show you just one case, part D for question number 2. So the cube looks like this, but between 0 through 2, it's just an increasing function. Okay, increasing function. That's all we care about. Okay, now interval is 0 through 2. So let's say we have four rectangles. So I had to divide the interval into 4 congruent segments. So this is going to be 1, and this is going to be 1/2, and this is going to be 3/2. Okay, left endpoint is x is equal to 0, and the right endpoint is x is equal to 2. Now to find the area, we want to know the width of each rectangle, and width can be found by finding the length of the total interval and divided by number of rectangles. So in this case, 2 minus 0 divided by 4, which is 1/2. So here is each interval have a length of 1/2. Now the height is going to be, because I'm going to find upper sum, I'm going to take a right point to find the rectangles. Right point, and right point. So the first one is f of 1/2. Second one is f of 1. Third one is f of 3/2. And the last one is f of 2. Okay. Now I have to plug in this one into the function fx is equal to 5x cubed. So it's going to be 5 times 1/2 cubed plus 5 times 1 cubed plus 5 times 3/2 cubed plus 5 times 2 cubed. So the first one will be 5/8. Second one is 5. Third one gonna be 27/135. And the fourth one is gonna be 40. Let's factor out 8. Let's factor out 8. Then it's gonna be 5 plus 40 plus 135 plus times 8, so it's going to be 320. Let's factor out 5. It's going to be 1 plus 8 plus 27 plus 64, which will be 100. So the answer is 16 or 500 over 16, which is 125 over 4, which is same thing as 31.25. Okay. Next, using rectangle whose height is given by value of the function at the midpoint of the rectangle's base. Estimate area under the graph using first 2 and then 4 rectangles. So it is just using a midpoint. So if we are using the calculator, it's quite simple. So we just have an x cube here. And the interval is not starting from 0. Oops, but starting from 1. So the interval is 1 through 2, function is x cubed, and number of rectangle is 2 and 4. So let's just do for 4. Okay. And it's already using a midpoint Riemann sum, which is, well, this is quite bad. Can we change to fractions? Can we change to fractions? I don't know. Let's see. Can we convert it to fractions? Not too sure how to do it. I guess I had to pay something maybe. Well, this is the answer, but I had to answer it in fractions. So maybe I had to use some other calculator to do it. Well, let's do it by hand. So I'm just going to do second part. So again, you have a cube function. And the interval is from 1 through 2. Okay, I'm gonna find the area under the curve. Now, suppose we're gonna divide it into 4 subintervals. So it's gonna be 3/2. This is 1, 1, 1, 4, so it's gonna be 5. Like this. But for each rectangles, you are not going to take left end or right end, but you want to take midpoint to get the height. Okay, here you want to take a midpoint to get the height of the rectangle, and here you want to take a midpoint to get the height of the rectangle, and you want to here take a midpoint here. So what is a midpoint? Well, it's gonna be here's 1, here's 2. So this is basically you're taking midpoint means you want to take like ace. So this is 1 and 1 ace. Here is 1. Here's 10 ace, 11 ace, 12 ace, 13, 14, 15. Okay, wow, it's very ugly. Okay, so you're gonna find the height at this point, this point, this point, and this point. Okay, so area is going to be, so each rectangle has a length of 1/4. Okay, remember that number of rectangle is 4. Left end point is A, right end point is 2, B is 2. So the common width is B minus A over N, which is 1/4. Now height is gonna be F of 9 ace, terrible. F of 11 ace, terrible. F of 13 ace, and F of 15 ace. We really need a calculator to do this one. Well, so you have to cube this one. So 9 ace cube and 11 ace cube, 13 cube, and 15 cubed. So 8 cube is 512. So it's gonna be 2048. Well, I shouldn't say that. Let's say this is 2 to the power of 9. Okay, so let's factor out 8 cube. 8 cube is same thing as 2 to the 9th. So including 4, you want to get 2 to the power of 11th in the denominator. And I have to do this sum. Well, yeah, we just use a calculator to do this one, but the 9 cube is going to be 729. 13 cube is, 11 cube is 1331. That's not too bad so far, but the 13 cube, I don't know, I don't remember, so I had to do some computation. Maybe this is simplified. Let's try. So this is sum of cubes, so maybe it can be simplified to 13 plus 20, 15. 13 square minus 13 times 15 plus 15 square for the cube formula. It's going to be 28 times 168, 195, 225. It looks nice. So this is going to be 199. 28 times 199. Sounds good. So it's going to be 1 over 2 to the 11th times 2060. 2060 plus 28 times 199. Okay, this is reducible by 4. So divide, factor out by 4. So it's going to be 515 plus 7 times 199. Terrible. It's very bad if we try to do it manually. So it's a 515, just stay here. So 7 times 199 is 1393. So it's gonna be 2 to the power of 9, 1908. So we can divide it by 4. So it's gonna be 2 to the 7, and divided by 4, it's gonna be 477. Okay, that is equal to 477 over 128. So doable, but not worth it, I guess. So just use a calculator. Yeah, once you, well, important part is you just be able to set up the correct equation. And the good thing about the Symbolab is it gives you the correct equation here, or idea here, okay? Okay, this is just a review question. So I'm gonna skip this. Well, again, this is just a product of mixed numbers. So change into improper fraction, multiply it, and then convert to mixed number again. Okay, so I'm gonna skip this, I'm gonna skip this. Okay, next one. Using rectangles, each of whose height is given by value of the function at the midpoint. So this is midpoint rule we have to use. Estimate the area under the graph of the function using 2 and then 4 rectangles. So basically this is same thing as the previous question. So basically you just need to use this. So it's going to be 8 over x to use. Domain interval is 1 through 5. Now let's use just the 4 intervals. Okay. So it's going to be 12.597 after rounding to 3 decimal places. Okay, for 2 rectangles, just change this one to 2 to get the answer. But for 2 rectangles, maybe you can do it by hand. Again, this is same question. It's just use a midpoint rule and with a different formula. Just find the area with by hand or by calculator. Okay, now a slightly different question. The table below shows the velocity of an object at each sec as it moves along a track for 10 seconds. Estimate the distance traveled using 10 subintervals of length 1 sec with left endpoint value. Estimate the distance traveled using 10 subintervals of length 1 sec with right end value as well. So let me show you what this question means. So we have a table with time in second and the velocity as a centimeter per second. And the time is like you have 0, 1, 2, 3, 4, 5, and so on. Okay. At time 0, velocity is 0. At time 1, velocity is 5. Time 2 is 11. Time 3 is 17. Time 4 is 24. Time 5 is 36. Time 6 down. Time 7 down. Time 8 is 8. Time 9 is 3. And time 0, 10 is 0. So that's something you know it. Okay. Now, we don't know exactly how the velocity changes in these intervals. Maybe like this, or like maybe like this, or maybe like this. We really don't know about how the velocity changes between this moment and this moment. But that's not very important for this problem because you want to take a left endpoint or right endpoint to estimate to make rectangles. So first of all, let's try to find area under the curve using a left endpoint. Why do we need to find the area under the curve? It is because you remember that when you integrate the velocity with respect to time, you want to get the displacement, the distance we traveled. So that means that basically the area under the velocity curve is the distance traveled. So we can use the same rule. Well, first of all, if we use a left 10 intervals with left endpoint. So in that case, the first rectangle has a length of 1 times height at 0. Okay. And the second interval length is 1 and height is f of 1. Okay. And the third interval length is 1 here and height is f of 2. So if you keep doing that, the last interval between 9 and 10, you want to take a left endpoint. So it's going to be f of 9. So you just need to find the sum of f of 0 through f of 9, which is, according to the table, it is 0 plus 5 plus 11 plus 17 plus 24 plus 36 plus 28 plus 15 plus 8 plus 3. Plus 3. Stop. We are not going to use the last number because F9, that's the last one to use. We're going to find the sum of these numbers, and it's going to be 147. Okay, 33, 93, 121, 136, 147. Okay, so that's the answer. Remember that the G's values is a value of the velocity, so the unit inside the parentheses is centimeter per second. The unit for 1 here is a length here, which is a time difference, so it's going to be second. So multiplying together, what you get is 147 centimeter. For the right estimation, you're going to have a same interval length, but you're going to use the right endpoint to estimate, to make a rectangle. So you start with F1. For the second interval, you're going to use F2. Okay. If you keep doing that, the last one, you're going to use F10 to estimate this interval. So last one is F10. In this problem, so you start with 5 plus 11 plus plus 8 plus 3 plus 0. And you see that this 0 is replaced by this 0. So in this case, there's no change. So this estimation also gives you 147. Okay, next question, number 10. An object is dropped straight down from a helicopter. The object falls faster and faster, but its acceleration decreases over time because of air resistance. The acceleration is measured in feet per second and recorded every second after drop for 4 seconds as shown. Okay, so now we have an acceleration versus time. And we have like 5 moments. So acceleration is, according to the problem, it is a decreasing function. Decreasing function, okay? It's decreasing. Problem state. Acceleration decreases, okay? So we can assume it's the decreasing function. Now let's look at the problem 1. Find the upper estimate for the speed when time is equal to 4. Okay. Remember that when you have a position, when you differentiate it, you want a velocity, and when you differentiate velocity, you want to get the acceleration. So when you integrate acceleration, you want to get the velocity, and that means the area under the curve of acceleration, you want to find the velocity. Okay. So because it's asking for the velocity, we can just find it by estimating the area under this curve. Now we want to find the speed when t is equal to 4. Well, assuming at the beginning the velocity is 0. Okay. So using the upper estimate, so I have to use the biggest point in each 4 intervals. So I'm going to use 4 intervals. Okay. So it's going to be this plus this plus this plus this. And the length is 1 here. So velocity at time is equal to 4 will be, so each rectangle has a horizontal length of 1 second, and height is going to be acceleration at time 0 plus acceleration at time 1, acceleration at time 2, and finally acceleration at time 3. So that's going to be 32 plus 19.41 plus 11.77 plus 7.14. Oh, that's tedious. Okay. So that's tedious. 32, 31.18, and 7.14. It's going to be 3207. So it's going to be 70.32. The unit inside the parentheses is feet per second per second. And this 1 has a length of 1 second. So I multiply by second. So the correct unit uses feet per second, which represents some kind of velocity or speed. Okay. To find the lower estimate, you are going to use the right point because it's decreasing. So you want to have this and this and this and this. So lower left, lower point estimation going to be 1 times acceleration at time 1, acceleration at time 2, acceleration at time 3, and acceleration at time 4. Okay. So instead of 32 here, you start with 19.41 plus 11.77 plus 7.14 and plus 4.33. Okay, so you want to subtract by 32 and you want to add 4. So it's going to be what? 38, 42, 42.65. So it's going to be 42.65 feet per second. Okay. So the true velocity at time 4 second is somewhere between 42 and 70. Okay. Last question. Find upper estimate for the distance fallen when time is equal to 3. Well, how do we find the distance? You want to integrate the velocity. So we want to make a velocity curve. We found out that the velocity at time 4 is Well, at the upper limit was 70.32. But we didn't find it for time is 3, 2, 1, and 0. And we don't need this one. We need this part to find the velocity. So let's find the velocity, upper limit velocity upper for time equal to 0, 1, 2, 3. Well, at the beginning, the velocity is assumed to be 0. Okay, at time 1, we just have one rectangle here. Okay, just between time 1, the one rectangle, so it's gonna be 32. At time 2, so you wanna have these two red rectangles. So time 2, so you wanna integrate the acceleration for interval of 0 through 2, so it's gonna be 51.41. And at time 3, you wanna add this one, you wanna add this one, 3 rectangles, so it's gonna be 63.18. So 32, 51, 63. So clearly it's an increasing function. So we can use the upper sum by finding 3 rectangles like this. So this is gonna be the upper estimate for the position. So the distance traveled by time 0 through 3 gonna be 1 unit times the speed at 1 plus speed at 2 and the speed at 3. That's gonna be 32 plus 51.41 plus 63.18. That is 1466659. Okay. Okay, next question, number 11. Object is shot straight upward from sea level with an initial velocity of 600 feet per second. Assuming the gravity is the only force acting on the object, give an upper estimate for its velocity after 5 seconds have elapsed. Okay, so let's say, well, the velocity is starting from 600. And at each time that, at each second, the acceleration is 32. So although the velocity is 600 feet per second at the beginning, okay, so it's starting with 600. The acceleration gives, can decelerate, acceleration is working this way, make the velocity go down by 32 units each time. So it's gonna be like 568 feet per second after 1 second. And after 2 seconds, you wanna lose another 32. And after 3 seconds, you wanna lose another 32. And 32. And 32. Okay. So after 5 seconds, the speed is decreased to 440 feet per second. Okay. Now, why I found all of these? Because there was a second question. So second question is to find the lower estimate for the height after 5 seconds. So to find the height, to find the distance traveled, I want to find the area under the velocity curve. So velocity starts from 600, but after 5 seconds, it's kind of decreasing like this way. To find the lower sum, the problem say delta t is equal to 1. So each interval should be length of 1. Okay. So I'm gonna make 5 rectangles with right endpoint for the lower sum. Okay, because it's decreasing function, we can use the right endpoint for the lower sum. Like this. So the distance traveled, the lower sum will be width times height which is going to be velocity at time 1, velocity at time 2, velocity at time 3, velocity at time 4, and velocity at time 5. So I had to find this sum, which is same thing as average of this number times 5, because this is linearly decreasing. So it's going to be 2520, 2520. Okay, and the unit will be feet per second for the velocity, and this length is second. So multiply together, you're gonna get the feet as a unit. Looks very ugly number. I don't wanna do it by hand basically. Okay, use a finite sum to estimate the average value of f on a given interval by partitioning the interval into 4 subintervals of equal length. So now you have a new terminology here. It's asking for average value. Okay. So what does it do? What we need to find. So what this is asking is actually, so you have an increasing function. So let's say this is like water in some kind of weird, strange container. Okay, so you've got some kind of cross-sectional area. And we want to have a same area, but make it to same height everywhere. Okay, so the area is the same, but the height gonna be kind of stabilized into like this. This height is called the average value of this function over the given interval. And how do you find it? Well, basically, the average value, average of the function on the interval a through b can be found by area under the curve, which is definite integral like this. You find the area and you divide it by the length of the interval. Okay, so basically you estimate the area using rectangles in this section and then just divide it by length of the total interval, which is 2. So let me use this one because I'm tired of computation. So I'm just gonna find the area under the curve by estimating with how many rectangles? 4 rectangles. So 3 through 5 with the function is x to the 4th. And the number of rectangle I have to use is 4 according to the problem. So I just use 4. And which interval I should use? Finite sum to estimate to give an interval, partition interval into 4 equal length average subinterval at the midpoint. It said midpoint. So I'm going to use a midpoint sum. The answer gonna be 5. This is terrible. It's in decimal. Oh my gosh. So what should I do? How do I change it to fractions? Can I just type fractions? Nope. I might have to use different one to find it. Well, anyway, so let me. Okay, well, let's use Desmos to do the computation. Okay, so f of x, yeah, is x to the power 4th. Okay, to find, divide it into 4 intervals, so I have to use 1/4 and times f of 3.25 plus 3.75 plus 4.25 plus 4.75. Okay. That's correct. Oh, 2 divided by 4. Oh, so this gonna be the sum of the all areas, which can be reduced into fraction like this. Let's say give the name to this one. So this is area. And we're gonna divide it by the length of the interval. So it's gonna be 286 and 73257 over 256. Okay, so that's the answer in fractions. Well, again, this is same thing. We just need to change. Again, it says the midpoint, finite sum, find average. So it's gonna be same things, but it's gonna be tedious. It's gonna be 2 over x. So the total interval is 9 minus 1, which is 8. 8 is divided into 4 intervals, so each interval length is gonna be 2. Now I have to use just 2, 4, 6, and 8 for the midpoint approximation, which is 25 over 6. 25 over 6. And so that's area. So now to find average, 8 divided by interval length, which is 9 minus 1, to find the average value, which is this. Okay. That was the easy one. Okay, next one. Again, you just need to do the same thing, but with different function, different intervals. And again, it's terrible. It's midpoint, but let's do it. Let's check it with this one. So interval is 4 through 6. 4 through 6. Function is 5.5 plus sine square of pi t. Pi t. Well, I should use pi x. Okay. A number of subinterval is going to be 4 again. And you want to get the 12 as the area under the curve. Now divide this one by length here, which is 2, to get the average value, okay? So maximum area is 12, but you have a length of 2, okay? So let me show you. Oh, oops. So what we just found out is the area under the curve here is 12, and the length here is 2. So when you make a rectangle with a width here is 2, then height should be 6 to have a same area. So this 6 is called the average value of the function in the interval. Okay, finally, question number 15. A tank is leaking. That's a speed. Tank is leaking at the increasing rate as indicated by the data below. Use the table to answer the following questions. So after 1 hour, 2 hours, 3 hours, the leaking speed, number of gallons per hour is changing from 30 to 720 in increasing rate. Okay. Find upper limit estimate for amount of material leaked after 4 hours. So we know the speed of the leakage, the speed of the total of the material leaked, okay? So the leak speed versus time. So leaking is unit is gallon per time, and the times unit is hour, the gallon per hour. So leaking is starting with 30, 50, well, it's increasing, okay, it's increasing for the first 8 hours. Okay. Now find upper limit estimate for the amount of material leaked after 4 hours. So it didn't specify what interval, how many rectangles I should use, but the natural choice would be the length of 1 for, yeah, because the number is given like it's like this for each feet for each hour. So upper limit can be found by taking this, taking this, taking this, and taking this. Yeah. So that's gonna be the total amount of the material leaked. Okay. So this unit multiplied this unit gives you total number of gallons. So first one, upper limit for the 4 hours after 4 hours is gonna be f of 1 times plus f of 2 plus f of 3 plus f of 4. And you multiply it by 1. 1 for this one, 1 hour, okay? So it is 1 times 30 plus 50 plus 150 plus 240. No, that's not correct. That was a lower sum. I had to use the right sum, so it's going to be start with 50, 150, 240, and 310. So for 750 gallons. Okay. Okay, so part B is lower sum after 4 hours. So lower sum, because this is increasing, I'm gonna take a left endpoint for find this, 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 and this. Okay, so lower sum is gonna be 1 hour for the width times f of 0 plus f of 1 plus f of 2 plus f of 3. So that's gonna be 1 times 30 plus 50 plus 150 plus 240, which is 470. Okay, 470 gallons. So this is the lowest estimation. This is upper estimation. So the correct value should be somewhere between 470 and 750. Now part C is basically same thing. So it's just like after 8 hours instead of 4 hours. So what you need to do is 1 times f of 1 plus f of 2 plus f of 8. For part D, it's using a left endpoint. So it's going to be f0 plus f1 plus f7. Yeah, basically you already do f1 through f7 here. So don't do the addition twice. Try to use this result into here, okay? Now part E. If the leakage occurs at a constant rate of 720 gallons per hour after 8 hours, and the tank initially held 26,000 gallons of material, an estimate for least amount of time for tank to empty is what? So the leakage is increasing from time 0 through 8, like this, but after 8 hours, the leakage rate stays same at 720. Now, what is the least amount of time? So what is the fastest to empty the tank? Okay, fastest. So I assume the leakage amount to be the maximum. So I have to use the maximum waste. So to estimate this part for the first 8 hours, we already found out, but I didn't calculate it here, but it's according to the answer here, it's 3050. So we lost 3050 in the first 8 hours. Originally, there was 26,000. So after 3050, you left with 22950. Divide this one by number of hours here, which we don't know, but let's say each time you lose 720, right? So divided by 720, you want to get the length here. So divided by 720 to find area here. So divided by 720. I need a calculator. So So 229, well, I just do this one, 26000, 26000 minus 3050 for maximum loss in the first 8 hours for the expectation, and divided by 720 gallon per hour to get 31.875. So 31.875, that's the length here. That's gonna be the length here. Okay, so that's gonna be 31.875. Okay, the question is asking for the total amount of time. So I don't forget about adding 8 hours at the beginning. So total is 39.9. Okay, so finally for the F part, what is the longest? Most amount of time the tank to empty. So if we assume the leakage to be the smallest in the first 8 hours, the leakage is only 2360 for the first 8 hours when we take a left end, when we take a lower estimation. Okay, in that case, we only lose 2360 gallons in the first 8 hours. And again, after that, you lose 720 each hour. So divided by 720 to get the number of hours. So just change that part. So I just need to change this part to 360. So that's going to be 32.8. And you just add 8 to this one. You just add 8 for the first 8 hours, you get 40.8. Okay. So that's conclude the section. Okay. Thank you for listening.